Hi everyone, my name is Riccardo Magliocchetti, and today I would like to try to answer the following question. Is the Django ecosystem, or better, its API ecosystem based on Django REST framework async yet? Let's find out. So actually, I think I got the talk of the title of a talk wrong, so it's back. No. So sorry, it was a bit clickbaiting. But to my defense, I thought about this talk at the end of last year. So at the time, I was working as a backend developer for a couple of companies. The stack of these companies were like common one, like Django monolith, Django REST framework for APIs, and PostgreSQL as a database. Both code bases were mostly IO bound, because all the CPU-intensive tasks were just already delegated to queues, so already run in a synchronous way. And concurrency in both places, both companies, was based on processes. And so that means that with higher traffic, you had to spawn more processes, and spawning more processes means consuming more memory. And by consuming more memory, okay, check, this work, okay, so mic change. Like in both companies, we were using processes for concurrencies. So I was saying that with more traffic, you have to spawn more processes. More processes means using more memory. And using more memory means paying more money to the cloud provider you're using. So imagine your CTO or CFO or architect or team lead or whatever approaching your desk and saying, what can we do to improve the usage of these machines, what we pay, but we consume only 20% of CPU, but the memory is almost full. And so my interest in thinking about transforming these synchronous services into a synchronous one. So I was not interested in making things faster or having lower latency, just better use of the resources I was paying for. And possibly without rewriting my code or the API code from scratch. So, Django developers have been working on asynchronous support since years. And also the PsychoPG3, the asynchronous driver for PostgreSQL, has been released since, again, years. The possibility to have a full asynchronous Django backend is coming together. At the moment of writing, there are still some missing pieces in Django to have a service running completely asynchronously. And some synchronous code is reused also in the synchronous path. And this is possible thanks to some helpers present in the ASCII-ref package that bridge the two words. So you can go from sync to sync and the other way around. Now, Django REST framework choose another destiny. If you go to the discussion forum, you will see a discussion by its developers about discussing asynchronous views. And the decision was more or less like, OK, I see there is a package called Async Django REST framework available. We don't want to invest in the synchronous world. And so we delegate asynchronous support to external packages. So a quick poll, how many of you are using Django as a backend? OK, most of the room. And how many of you are using Django REST framework for APIs? OK, more or less half of the room, a bit more. OK. So the plan for this talk is the following. Let's create an API in synchronous Django REST framework and replicate the same using a synchronous Django REST framework. See what is working and what is not. As a man with little imagination, I've just choose to create a demo based on the Django REST framework tutorial, which is an application that implements a two model view set for the two Django contribute models, user and group. And in this application, each of these model view set has, of course, a model serializer. There is pagination. There is a default authentication and a router to handle the views URLs automatically. Sounds good. So let's try to implement the same in Async Django REST framework. And now we get into troubles. So first problem I got is that the model view set are actually not implemented in Async Django REST framework. Also the mixin that usually compose the view set in Django REST framework are not already implemented. So anyway, no big deal. For the demo, I just wrote all the views set by hand. It's like 30 minutes of work. And of course, I have implemented all the mixin that compose the view set. Otherwise, it will take a lot more time. So you have just a big bunch of big mixin with a bunch of methods. And each of the model view set, like one for user and one for group model, inherit from this mixin. Next problem is that the HTML rendering of Django REST framework API does not work in Async Django REST framework. Again, not a problem. Like to input my data, I just use curl calling the endpoints directory, and I create the user and group instances from the Django shell. Then serializer, another problem is that actually related fields are not handled for asynchronous code. And so in the user serializer, I have serialization of the associated groups for the users. And so this is not working. Again, no big deal. I just remove the field from the serializer and move forward. Then there's no permission implemented by default in Async Django REST framework. And so not a problem for this demo. So just I remove the authentication from my views. And then I gave up because quite a bit of problems. So jokes aside, I've tried to fix a couple of things I found like poking with Async Django REST framework. For example, to decide if a view set is asynchronous or not, only the methods of the viewset class were checked. So since I implemented most of the helpers, of the sync helpers in a mixin, the code was thinking it was a synchronous class viewset. And so I had to change that in order to run through the asynchronous code path. Then another problem in the API view class, sort of the same problem. Like it was reused the Django one, but is checking only the method named after the HTTP verbs. So like get, post, etc. Unfortunately, the view sets doesn't implement these methods, but implement like the actions, like list, retrieve, destroy, etc., update, etc. And so again, we were going through the synchronous path. Said that, after fixing these issues, I guess, I opened up a request because I'm still not able to have green tests. And so I'm looking forward for the response from the project maintainer. You can check the pull requests. So my experience with Async Django REST framework is that today is missing too much stuff to think of using it in the production. Said that, if any of you want to poke with a web framework or try to understand how things works in a synchronous world, I think it could be like a good opportunity to contribute and help with developing the missing bits. Now, I don't want to end this talk without an happy ending. And so I've asked myself, can I contribute something useful, like to having a fully asynchronous Django REST framework? And so, as I said before, support for synchronous views in Django is not 100% complete. So to reuse some already available synchronous code, We're using a couple of helpers from the sgref sync module. Sgref is the package, async is the module. They called async to sync and sync to async. And they usually, they just like permit to go from one word to the other. And so if you look at inside Django code, you see that some paths use these helpers to go like from asynchronous views to synchronous code and back. So, and I was wondering, I think it may be interesting to actually see how many times we use them and we go from a word to the other. So these days, I'm not working on Django backends anymore. I'm working on OpenTelemetry for Elastic. And if you don't know it yet, OpenTelemetry is a specification implementation of telemetry system to enable observability for your services. So I thought on writing what is called in OpenTelemetry terms an instrumentation. That is some code that tracks some other code and set the telemetry again of the user of this code to a system. And so in this specific case, I've created an instrumentation to track how many times, and also to provide the stack trace of the, like to find out where the code paths are that are going from async to async and the other way around. It's not something I suggest to run in production, but I think it's fun to run. So, demo time. Before I start the demo, I show you a little example on that use OpenTelemetry auto instrumentation. That is an instrumentation that does not require you to change your code, but you instrument code from the outside. So we'll use OpenTelemetry instrument. That is the tool that permits this auto instrumentation. And we'll just instrument the async version of the demo of the Django REST framework tutorial. And see, you see traces not sent to a real server, but on the console just for demo purposes. The demo recorded, but I can run it online if I need to. Oops. I'm sorry, I cannot increase the font, but I'll try to explain it. So we are calling, the volume. We're calling OpenTelemetry instrument. We're just sending the traces to the console, and we are calling gunicorn that is running with a worker and using a uvicorn as a worker class. And other than that, we are passing just the ASCII entry point to gunicorn. And so I guess also the lights doesn't help. Anyway, this is in OpenTelemetry terms a span. That is a unit of work. And what the interesting bits are this one. That is the stack trace. You can see from the stack trace, maybe I can highlight that, but it's really small. And we see that it's in the code path of the middlewares. So load middleware is calling, I guess, some helpers that are calling sync to async. Other than that, like I don't want to go into OpenTelemetry technicalities, but this is just from loading our application and not calling any request. And that was the demo. So hopefully I'm able to go back. Oh. Okay. So, to conclude, my impression is that in these last years, we only worried about the Django asynchronous support, and we mostly forget about all the ecosystem around, especially the Django REST Framework 1. So there's still work to do to get an asynchronous version of Django REST framework. And I usually the project called Async Django REST framework because the most advanced solution I found that is compatible with Django REST framework. If there are others, I blame the search engines. Other than that, again, it's not only a problem in the Django REST framework ecosystem, because a lot of the batteries that made like the Django ecosystem so great to work with are missing asynchronous support. And so I guess this is the right moment in time to play with the asynchronous support and maybe like try to contribute to fix any issues you get using external packages. I left on the slide a couple of references. First one is the wiki page from the Django documentation, then the discussion from the Django REST framework forum, then a link to the Async DRF project. DRF is Django REST framework. The link to the demo project on GitHub, a link to the OpenRemedy project, and last one is the link to the instrumentation I wrote for tracking AsGraph. That's it. Thank you. Glad you take any question.
Great talk. I think we have some time at hand, so if you have any questions, just raise your hand.
Hi, thanks for the presentation. And my question is that is not included in your presentation, but maybe you will tell me, did you notice the impact on the database when you switch to the async? Any performance across to the database connection, queries, etc.?
So the question is I found any database penalty, any performance penalty in that database path? Okay. I have to say I've just done this work as more for visibility of the issues than any performance benchmarking. And so for sure, the database path, the one that has still synchronous code. So, like, this doesn't really mean it will be slower, but this only means that it's not like the best possible performance you can get of the database. Say that. I don't think that will be like the biggest issue. Yeah.
Did you found any issues during the transition to the async? During that transition from sync to async, right? Did you found any problems related to the connecting to the database, making queries or something like that?
Thank you. So the question was like if I found any issues, problem like doing the conversion from sync to async. Nope, I haven't found any.
Any more questions?
So the last thing that you mentioned that you didn't see any problem switching between sync and async. I saw that you were counting the number of times that you are doing it, but did you try also to measure the overhead of switching between these threads of sync and async?
So the question is if I found any, I measured the overhead information from sync to async the other way around. No, I didn't measure that, but I think that will be, I wouldn't say pointless, but it's like our current state of things. It just, you have to accept that you have this overhead. And so I guess the most interesting part will be like doing benchmarking from like from the user point of view. So latency or maybe some metrics on your machine, like memory savings or like being able to serve more requests with the same resources, stuff like that. Because like benchmarking internals like that, you can't act on that. You only take into account. So if it was me, like I just measure the end-to-end performance of the service, like from my user point of view. Thank you.
More questions? Okay, I think then we are done. Thank you, everyone. We'll meet again at 3:25.